Okay, welcome back to the deep dive. Today, we're going to look at something that, well, you might remember from a math class, maybe differentiation, integration, that sort of thing, and see how it actually pops up in the real world. It's pretty interesting. We've been looking at sources covering integrating sunlight for crop growth. Now, integrating sunlight, I mean, it sounds a bit abstract, doesn't it? Like, what's math got to do with, the sun hitting plants? But the real question here, the one the sources dig into, is actually quite practical. It's how we can use integration to figure out the total sunlight a crop canopy gets over time.
Yeah, and it's really key to understand why you'd even want to measure that total amount. I mean, light drives photosynthesis, right? That's how plants make their food, how they grow.
Yeah.
So the growth potential, it's directly linked to the total light energy captured, not just, how bright it is right this second.
Exactly, because it's not like the sunlight hitting a field is just constant. It changes a lot. Sunrise, sunset, cloudy days, clear days. And even like as the plants grow taller, the canopy changes how much light gets through. So just knowing the intensity now doesn't really give you the full picture for the plant's energy budget.
That's precisely it. Light intensity is a rate energy per time, per area.
Hmm.
And since that rate is always fluctuating, you can't just take one measurement and multiply it by, say, 24 hours to get the daily total. You need a method to sum up all those changing rates over the whole period.
Which is basically what integration lets you do. It's the math tool for adding up the effect of something changing over time, like speed and distance, right? If you're going at a steady speed, you just multiply speed by time. But your speed changes, you have to integrate that speed over time to find the total distance. Same idea here, just with light intensity.
Exactly the same principle. You integrate the light intensity rate to find the total light energy that sort of traveled into the canopy. And the sources talk about how this is done in practice. Researchers, farmers, they use these sensors, often called pyranometers. They place them in or above the crops to measure the light intensity at any given moment. Specifically, the PAR, that's photosynthetically active radiation, the stuff plants use.
Okay, so you're gathering data points all day long, like intensity readings maybe every minute or something.
Pretty much, yeah. You collect these measurements over, say, a full day, and that data gives you a curve showing how the light went up and down.
And then you do the integration on that curve.
Yep. You take that data, that curve of intensity over time, and computationally, you integrate it, like summing up countless tiny rectangles under that curve. Each rectangle is a tiny bit of time multiplied by the intensity during that time. The final number tells you the total light energy the crop intercepted.
Ah, so it takes that whole dynamic day of changing sun and boils down to one useful number. I think I've seen that called the daily light integral, DLI.
That's it, exactly.
Oh.
DLI is a very common application of this. It's the result of integrating that PAR intensity over 24 hours,
Yeah.
usually expressed in moles of photons per square meter per day. And it's super useful because, as the sources point out, it correlates really well with potential growth, biomass, yield for lots of crops. Different plants have different DLI needs, their sweet spot.
Wow, okay, so it's definitely not just math for math's sake. This gives farmers and scientists real info. They could use DLI data to maybe pick crop types that fit the local light levels or tweak greenhouse lighting.
Absolutely. It connects that fundamental energy input light directly to how the plant performs. Understanding the total light lets you model growth much more accurately, predict yields better. It's way beyond just counting sunny days. It makes a variable thing like sunlight into a number you can actually work with in agricultural science.
Okay, so wrapping up this deep dive, we've seen integration, that calculus idea of summing up changing things, being used in a really practical way in farming. It lets us calculate the total sunlight energy plants receive over time, often called the DLI, which is crucial for understanding and predicting crop growth.
Right. And it makes you think, seeing how a math tool like integration helps quantify a dynamic natural process.
Right.
Where else might this idea be working, maybe in less obvious ways all around us?